Edward Traxler's here and Peter Levos, and Ed's going to show us how he uses SketchUp to create 3D models for 3D printing. And what we're going to make is a tire swing for a future kit that I'm going to design. So I'm going to focus on Ed here, I guess. We're going to depend on Ed today. You're the champ today, Ed.
Yeah.
So, Ed,
yes.
I guess the first thing we should say is you're using SketchUp. There's two types of SketchUp. A pro version that's worth about $250, and then there's a free version. We're using the free version, correct?
You are correct, and you are wrong.
Okay.
The pro version is almost $600. Yeah.
Yeah.
But, no, I use the free version. The pro version does a lot of stuff that if you were an architect and you created a building, then you want to generate the plans, okay, print them out that you can make blueprints and publish them and hand them to the contractor. In that case, the $600 makes sense because you can do every part. You make a database, print it out. He can take it down to Lowe's and buy all the stuff, that sort of thing.
Okay.
But being a cheap person and not an architect, I use the free version of SketchUp.
So as a model railroader, we would suggest that the free version is all you really need.
Yes. Now, I'm not knocking the other CAD programs, and if you got it, like SolidWorks, but then I don't have $7,000 to pay for SolidWorks, okay? Not for a hobby. SketchUp does basically everything I need to do.
Okay.
So, when you're designing for 3D printing, this is what we're talking about, the things to keep in mind are the constraints imposed upon the printing process. Now, I use Shapeways. There are other companies that do much the same thing. I Materialize and some others, okay?
So the restrictions are basically the wall thickness, and then also the vertices, the polygon planes.
The material, okay, there's two restrictions. One is the file, which is Shapeways has a 60 megabyte file size and 1 million polygons. Okay, that's irrespective of the material you're printing in. Your material constraints, you have to understand that they've got a bunch of machines, and there's when you say 3D printing, there's all these different types of 3D printing. Some uses a laser beam, some uses, in other words, there's a white, strong, and flexible is a powdered nylon that a laser beam actually melts it. There is a version that squirts out the layers, much like an inkjet printer, and then UV light harden it. And there's a wax process where they use to, same as a jeweler, a lost wax process. They print a piece of wax out. They basically do an investment casting. So depending on the material and the type machine, you have wall thicknesses, you have minimum details, you have wire minimum diameters, and so on. And you have to keep that in mind at the back of your mind when you're doing this design. Does that make sense?
Yes.
Okay. For us, and I say modelers, there are Shapeways. There's two products that we normally use. One is the white, strong, and flexible, which is a centered nylon, which means that what they do is they put if you can imagine, take a squeegee and you form a layer of this nylon powder and use a laser beam and you melt it. And then you layer another layer and you melt that layer, another layer and melt that layer. But it is a rough surface, and under certain conditions it works fine. In O scale, to me, it looks like a heavy cast iron texture, if you can imagine what I'm saying.
Yeah, pitted. But in terms of 3D printing, what this material you're talking about, it's the old stuff, isn't it? Like there's newer materials that you can print in.
Well, there's newer materials, but you always got to read. You always got to read in between the lines, because they're trying to sell you a product, right?
Yeah.
And they will boost the cool parts and not talk about the part that sucks. Well, I mean, that's like everything, right?
Yeah.
In other words, yes, this nylon, and I've got an example I can show up on real quick. Let me go to my, I didn't have this. I had the other screen ready, and of course I got to show you something different. But I made some bridge shoes a while back. Okay. Now, I printed these in both here is, okay, let me share this screen. This is O scale, and that is a bridge shoe that's printed in what's called FUD, which is frosted ultra detail.
Okay.
And it's just nice and smooth. It looks pretty. It's sitting on a quarter. But the problem with that is it is relatively delicate.
Oh. In what way? Like by squeezing it with your fingers?
The material, the best way to describe it is take our clear styrene. You know how it's brittle and you drop clear styrene, a lot of times it'll shatter.
Yeah.
And take week old cake frosting, mix the two, and that's about what FUD is like.
Oh, okay.
All right. It's fine for detail parts. It's fine for looking at, but don't. If you stepped on that bridge shoe I just showed, it would crush.
Oh, okay. I see. Like a corrugated box.
Well, remember, it's a layered. What it's done, it's sprayed down. It's an acrylic polymer. It's hardened layer by UV light.
Okay.
So and it's an acrylic. It's just a paste, that's hardened. So it's not like really strong.
Yeah.
Now this picture I'm showing here is the same shoe, a bridge shoe that's imprinted in white, strong, and flexible.
Okay.
It's this stented nylon. You can see the texture, right?
Oh, I see.
Because I stained it. But it works fine for specific. In this case, it's supposed to be cast iron, and I go, well, it looks like cast iron.
In O scale, it would be more realistic as cast iron than in smaller scales, but I see what you're saying, yeah.
And you asked me, well, why would you use this in preface? Because I could stand on this and it wouldn't break.
Oh, cool. Okay. That's a big.
This is more like a Durlin, like your black slippery plastic. It's more like that. It's not as smooth, but in strength, it's similar to that.
So, FUD is a better material for model railroading because we don't really sit on the layout ever.
Correct. Now, this, I would suggest that if Ron Pare wanted to model an 0-30, but he wanted a 4884 narrow gauge locomotive, you could buy some Bachmann parts or HO mechanism, because it's the 0-30 is the gauge is the same.
Yeah.
Remove the guts and design and print your own frame.
Oh.
And you could print it out of this stuff because the frame don't show.
Oh, wow.
and you can put the bearings, the wheels, all that. So you strip the body off of a steam locomotive.
Yeah.
You have just a crude looking frame that all the little bits attached to.
Yeah.
That would work fine for that. You would be just like you were printing in a Durlin frame.
Oh.
Okay. So, but you're correct in the fact that for our purposes, for the purposes of a model, just a look is what a lot of our stuff does, right?
Mm-hmm.
The FUD's a better thing, but it's more expensive. So if you were going to do a body, when people actually do print, say an O-scale trolley, they'll do it in white, strong, and flexible, and then what they do is a couple of good layers of primer and sanding, that sort of thing to get. It's a lot of work
to tone down the pitting.
Yes, but what you would do is basically do the body, and people have done it, and it kind of looks like a vehicle's been sitting out for 60 years. Okay. By primering and a couple layers of primer and some sanding, you can get rid of that, but it's additional work, and most people do not want to take the time to do that. Right.
Just to make note, though, people have been trying to model vehicles that have been sitting outside for 60 years forever. So yeah. That's not a bad point.
No, well, it's a point that if you're providing these, majority of people are not wanting to take the time that would be required to turn the white, strong, and flexible with this little texture.
So it's not a master material for
Joe Blow, no.
Yeah, so you could make this into a nice master to remold it and then make it out of resin or something like that. But
well, if you were going
3D printed model isn't really.
If you were going to make a master, then I would suggest you go FUD, because it doesn't matter how strong the master is.
Yeah. Yeah.
Okay. It would cost you more. The difference would be if you did a O scale, or say a HO engine.
Yeah.
Body. It might cost you $30 in white, strong, and flexible.
Really?
It might cost you $120 in FUD.
Oh.
Okay.
And is that costed by the ounce?
Yes. No, it's by cubic. Okay.
Good question, Peter. You stumped them.
No, I'm not. How to put this? In FUD, it's $3.49 a cubic centimeter. Okay.
But that's not overall space. Like if you have a hollowed out model, that means that you're.
That's machine space. You're talking about machine space. No, it's charged by the cubic centimeters, the volume of the material.
Yeah. Okay.
Okay, and we were talking earlier about doing this tire. Is yes, you want to hollow it out because you don't want to pay for the excess junk, right?
Mm-hmm.
If you're white, strong, and flexible, for white, strong, and flexible, it's $1.50 per part. Then it's like whatever $2. It's whatever the cost is per. Actually, if I go to actually, I can just bring you straight to the website. You know, we may have to extend this. We haven't even got to the tire yet, but this is interesting stuff. If you go to Shapeways, I go to the website, and you go to Design, and then you go to Materials. This is all your materials. It gives you every, say, strong and flexible.
That's metal, sterling silver.
Oh yeah, it's got gold and everything. It's the price is $1.50 a part, 0.28 cents a cubic centimeter, and then 0.21 cents machine space. So remember, you said if it's hollow, with FUD you're not charged machine space. You're charged only for the cubic centimeters of material. With here is white, strong, and flexible. So you're getting charged 0.28 cents per material, but 0.21 cents for the machine space it occupies, and $1.50 a part. So, when you ask me how much does it cost, it's like it depends, like everything else in life. Yes. Okay. No. So that's
So our tire will be made in FUD.
I would not. Oh, that's a switch stand I was doing. I closed that. Okay. So
Peter, we're bleeding into your audio.
What's that?
We're somehow bleeding into your audio.
I'm all of a sudden we got an echo.
No, it's fixed now.
Oh, it was Mr. Peter. Okay.
When he's got a question, he'll just pop off as mute.
Yeah, just jump up and down.
Feel free.
Let's see. Okay. Since Ron has a time limit today because he's got to take Mom out to eat or something.
And the wife. I'll bring her too.
Yeah. So let's look. This is a SketchUp screen as you open up. Okay.
Yeah.
And real quick, you got You got your Z-axis, your X-axis, and your Y-axis. Standard stuff, right?
Yeah.
Now, when you're drawing on a screen, you can sometimes get it at the angles you want.
Oh, I see. Yeah, that's the problem that I usually have, is trying to get things to go where I want them on the plane.
Well, that's easily fixed. What you do is you draw a little square, you pull it up, and then if I want to draw a circle on this plane, I got to put it on the same, I hold my shift key, and now it stays on that plane anywhere I want.
Oh, wow. That's
Okay?
a nice trick.
If I want to take that block and make that a group so I can maneuver, I hit M on the keyboard, and I say I move it to 45 degrees, right?
Yeah.
Now I can sit there, put a circle on that surface, hold the shift key, boom, it's at 45 degrees.
Oh, that's a good trick.
Okay? Now,
Yeah.
let's go control. I'm hearing myself again.
I'll mute.
All right, so now we want to make a, but see, I like the interaction. I need to hear you so you can ask questions.
I'll pop up. I'll ask.
I'm just wondering why I'm hearing myself.
I think it's
You're not on, that's because I'm hearing your speakers, I believe. Anyway, I want to hear your microphone, but okay.
How's this?
Sounds pretty good.
Okay.
I can live with it.
So can they.
Okay.
We're all adults.
So we're wanting to do a tire. So normally what I do is I just draw a flat plane to work off of. That's like a sheet of paper. All right.
Okay.
Now, in this case, we don't have to do that because we're going to pull in a tire shape. Now, you want to do a tire.
Yeah.
So I'm going to go File. I'm going to go Import, and I'm going to import this GIF right there. A PNG, I'm sorry. This is a cross-section that I found on a website of a tire from 1927.
Awesome.
Okay. So, that's fine. We'll just use that. And over the side, I can use this image, use this texture, use the match photo. I use this image. I go Open. And what that does, I do that. I go Camera, Parallel Projection, because I don't want perspective at this time. I go Camera, Standard Views, Front, and now I'm looking dead on at that cross section. And what we're going to do is trace around this. Now, if you were doing a modern tire, if you had one to measure, you could do that. or if you had a cross section of a modern tire, that's fine.
Yeah.
But since we're explaining how to do this, this works fine. So first to do, I'm drawing directly on top of it, and I'm finding the center. You notice that it turns blue right there?
Oh, I see. Okay.
That's the center of this line. I just drew this line from edge to edge. Boom, I'm in the center. I click once. Now I'm using my center scroll mouse to scroll in and out, okay?
Yeah.
Now, say it's at angles, but now it's in the blue line. That means it's on the Z-axis. I click. Boom.
It snaps to the axis.
Yes.
Yeah.
It turns blue. In other words, if I'm drawing, if I look at an angle and I click here, say it's on the green axis, that's my Y.
Yeah.
It's red, it's on the X. It's blue, it's on the Z.
Okay.
Okay, let's go back to
Front.
right. I'm gonna go window, go camera, standard views, front. Right.
I like it that you're saying these menu items as you go, so that people can come back and possibly copy what we're doing.
Yeah, what's
with their own image of something, or with the tire. I don't care.
It makes a big difference. Now I'm gonna change the scene to more of a neutral background. Okay. So all we're going to do is sketch on top of this. In other words, the edge of the tire comes up right here. Okay, I know that much.
Yeah.
So let's just draw a line across this. See, once you fill in Control Z. Control Z is good.
Always.
I click inside, and I hit the delete key, and it just gets rid of that. I'm just showing out.
And when it came dotted, when the plane became dotted, that means that is selected.
Yes.
Okay.
So I want to go from here down to here. Now this tire here, evidently, the tread was actually only up in this area here, I believe.
Yeah.
I'm not really sure. It may have come all the way to here. We're going to put the tread all the way to the edge.
Okay.
But that's one of those things where you've got to figure out, you know, how was the darn thing designed? You have to look at a picture.
Yeah.
You go online, you go to Google, and you go. Now I'm gonna hit. These are all your icons, but I hardly ever use these. I use the
keyboard shortcuts.
Keyboard. An arc is just A. Wow, how wonderful is that, right? I zoom in. Say I'm on the. When I'm on the line, see it, boom, it turns red, right?
Yeah.
So I click there. I zoom out. I click there. Now I'm going to zoom in. Looks like the tread went like that. So I clicked once. I clicked here. Now the arc's connected to the cursor.
Okay.
And I click. Boom. It just filled that in.
Sure.
Again, because I completed the polygon of the shape, it filled it in. But I'm going to hit delete because I want to see the inside, right?
Yeah.
So that's about right here to about right here. I hit arc. That's a straight line. I don't want that. Hit eighth arc. There, and about there, I say. And it didn't fill in because there's no completion. Okay.
Yeah.
Right. Now, if I come across and make a line, it fills in.
Yeah. Closes it off.
I can do the same here, and it didn't fill in because I don't have a vertical. See? And you might ask, why are these blue?
Because they're selected?
No. It depends on which direction you make the shape. It tries to determine if it's outside or inside of the polygon. The blue says that.
I'll be right back.
Okay. The blue says that this is the inside polygon. So I right click, I can reverse spaces. I just do that to now I got to come up and around and touch. So I delete that so I can see what I'm doing. And it's hard to tell right here if the shape of the tire. I'm just going to go with, again, you want to go to a Google and look at tires and see what they're shaped like. But it looks like that this shape comes up. We know that a tire rim, it comes up a little bit, and then hit A for arc, and I'm going to come up to about right here, and I'm going to say, okay, let's just go from here to here. And I'm going to go from here to here. So I'm playing around until I get a shape that looks kind of correct. Because, again, I'm not worried about Control Z because I just deleted everything. So what I'm doing here is basically shaping this I'm getting rid of the stuff I do earlier, because so I got a shape. It comes up. It basically comes up right here and comes up that way, right? And I say, okay, it looks like that'll work for the. Control Z is your friend. I keep saying that, but it's true. And what I'm doing, I'm using just the cursor to click individual lines. Right?
When you say Control Z, is that the quick for erase?
That's for undo.
Okay.
If you look up, it's if you go edit, undo erase is alt backspace works, but also Control Z works too. Okay, so I'm getting rid of all my excess lines, and I don't like. By the way, I don't like this style. It leaves little dots where you're trying to work, so I'm gonna go to that one. Okay. By the way, Windows styles. There's all these different styles of your drawings, your background, and all that sort of thing. Okay. So now I'm gonna delete that shape again so I can see the outside. I'm going to repeat this on the inside. Now, we were talking about making it hollow earlier. And this is one of the places where at some point we're going to have to make a decision about the wall thicknesses. Okay? No. Oh, see, I was trying to see where I forgot a line. It didn't fill in. And I don't need that tire no more because I can eyeball this. Because, again, this is a model. This is not going to be on the road. We don't care about that. So, there's basically our tire shape. This is the point where I would save this as 1927 tire full-size template, because now we're going to say what scale are we going to make this tire in. And I'm assuming, since Ron has ran away, that he's going to work in HO. Okay? So what I would do, I go File, I go Save As, and let's just make a little folder. I've got this is in my micromimesis.com website folder thingy. I got a folder called Tires and Wheels, and let's go. We're going to create a folder, and I'm going to call it Ron's Tire. And I'm going to save, first I'm going to save it as, that's a 1927 tire template, okay? That's so when I blow this thing up, I can go back and reload it. Now you say, well, Ed, we want to make this HO. So remember this little block we made?
Yep.
This is the dimension tool, right? I didn't make it any specific size. Okay, I'm going to make that 12 inches just to have something, just to show you guys. It's 14.867, right? So I'm going to select the side, hit P for push in 2. What was it? 687, 487? I don't remember.
Yeah.
Okay, I'm going to push in 0.38. So I go push 0.380. Now if I go back in dimensions, 12 inches, okay? The reason I'm doing this is this tire that you want, Ron, is HO, correct?
Yes.
Okay, so HO in is 0.138 inches. I could change this to 0.138, but we run into a problem with SketchUp. SketchUp was originally designed for architects. Architects do not work in micro inches or millimeters. They work in feet and inches. SketchUp will not make, if I try to draw a circle, and I make a circle, if you look down at the bottom down here, it shows you the radius. 2 inches, that's fine, that works fine, right? If I go in smaller, 0.7 whatever works fine. If I go smaller, I make a thing that's 0.3 or 0.245. That works. But what if I go 0.1? What if I go, and we're going small. Let's go 0.24 works. But 0.10, it says radius is too small. I cannot make a circle smaller. I can make a 0.018, but I cannot make a 0.017. That is a problem because Ron, what is 0.018 in HO? What's that, like 2 inches or something?
I don't know.
Well, okay, 0.018 times 87 is 1.5 inches. So we're saying the smallest I can draw in HO is an 18,000th diameter radius, or that's a 3-inch. It's a 1.5 inch radius or a 3-inch diameter or something, and that is not good because there's a lot of HO stuff are smaller than 3 inches. Correct?
Yeah.
All right.
Like
How to get around that? 12 inches. So we're going to switch to what I call is a pseudo millimeter. 12 inches. If I divide that by 87, it is 0.1379 or 0.138 inches. Correct? Just nod your head up and down. All right. I'm going to change it to millimeters. Times 25.4 is 3.5 millimeters. So I'm going to rescale this to, see, I use my tape measure tool. See how it says 12 inches? I click the N, I type in 3.5, I hit enter. It says, do you want to resize the model? Yes. Now, I am not worried that that's not actually, we're still in inches. If you look at the window model info, it says decimal inches, right? I don't care. I'm going to assume this is millimeters. And the reason is, since you were actually in inches, I can go down below 0.018 and all that. You see what I'm saying? Although we're actually, if this is millimeters, this is a HO side. This is HO size. Now I can measure directly because the minimum wall thickness in FUD, okay? And by the way, before I start, I'm gonna stop it. That's doing
kind of like how I look like in SketchUp. You're just doing a demonstration of me.
Okay. This is a good example of
Mirror image.
I'm going to put the color back in just so I can see where what filled in or not, right?
Mm.
And I filled this in because we need to modify this wall thickness to meet the constraints for FUD. Now we're in the HO, we don't care.
Mm-hmm.
All we know is that this if I hit T, my tape measure tool comes up. I double click on that line, it gives me a guideline, right? So we're saying that for FUD, the minimum wall thickness is 0.3 millimeters, right?
Yeah.
So that's 1.9 millimeters right there. Because remember,
so we're well within our thickness.
Well, we just double check that this is 1 foot in width.
Yeah.
The problem is that we skipped a step.
It's all good.
Well, okay. How wide is this tire? So what I'm saying is, if I make a copy, what we failed to do was we got all excited with Ron telling me his war stories. Is we forgot to actually scale our draw. Remember, our drawing was. Oh, by the way, I'm skipping ahead. I'm doing stuff without telling you what I'm doing. I grouped the object so I can
copy and paste it.
Let me explode. So this is this drawing. It's got all the, and you click on it, and it selects it and all that, right?
Yeah.
I want to do stuff to it, so I use my cursor. I draw a box around it. I let go. I right click. I go make group. Now, see, I can't affect it unless I double click and get inside. I can't affect that.
Well, that's cool that you can still access those different parts by double clicking.
Oh yeah.
Oh.
So now I hit M to move. I hit Control key one time, and I hold my right arrow key to constrain the movement to the X-axis, and I move a copy.
Oh.
I hit S to scale. I grab that, pull it completely through until it says 1 in the bottom right. Or I can just type in -1. I'll let go, hit M, come over, because all I'm doing here is we're going to modify this a little bit.
Well, they'll snap together when they get real close, right?
Well, if I move this and I see if I grab it, see how it makes a little purple dot?
Yeah.
Around the corner. I'm holding that purple dot and I touch right there, and it hasn't stuck because these are two grouped objects.
Mm.
Right?
Yeah.
Now I'm going to ungroup these because I'm just doing an example as a copy. There's something else here too. Yeah, let me leave the center line in there. You see how it dips down?
Yeah, I seen that. I was going to mention it, but figured forget it.
No, that's fine, and that's simply because when
the arch went past the.
Yeah, I just drew. So let's see. That looks like the horizontal. See the top horizontal line right there?
Yeah.
If I double click and go inside, then I can say I can click here. I just do a horizontal. See, I'm just doing a line on the red.
Yeah.
And I can what they did, that filled that in. Okay, so now it's flat. Right? So, this is a 1927 tire. How wide do you think it was from here to here?
8 inches?
Okay.
What do you think, Peter?
I'd be guessing.
You would do some research. you're going to Google and you're looking around. So that's my. So we're going to say, okay, that's 8 inches from here. And I say, what I'm going to do is I'm going to hold my right arrow key to constrain to the red axis. If you don't do that, then it can move anywhere. So I'm going to move, and I'm using my guideline to click there. Right, so we said that was 8 inches. So what I'm going to do is draw a line from there to there, and if you look, if I hit my dimension tool, that's actually right now at 8.9 inches. And we go, oh, well, darn, and actually it's not 8.9. You see, we're confusing ourselves, remember?
Because we're doing millimeters, right?
We're doing millimeters, right? So that's 8 point, let's say, you said 8 inches, which this width would be 4 inches, correct?
Yeah.
Okay, so 4 divided by 87 is 3.459. You do this again. 4 inches divided by 87 is 0.0459. So it's 46 thousandths. Got me?
Yeah.
Ed, can I ask you a question?
Sure.
Does it matter which metric, whether you're using millimeters or inches? Because can't you rescale it at time of export or at time of printing? Remember at that on the printing screen when I remember it from inches to HO.
How you scale it is up to you, but there's a reason I work in millimeters. I'll show you that in a second. You can go the other way, but it's just you gotta. It's like whatever you do, there's always multiple ways to do it. This is the way that I like to do it, and there's a reason. I'll show you in a second. In HO, we said this tire was 8 inches across the width, right? And 4 inches divided by 87 comes out to 46 thousandths. It's 0.04. It's like whatever you do, there's always multiple ways to do it. This is the way that I like to do it, and there's a reason. I'll show you in a second. Oh, in HO, the half of width of the tire is 46 thousandths. So I'm going to multiply that times 25.4. It's 1.1684 millimeters. So I'm just going to rescale this whole thing right here.
Okay, Ed, just to pop in here, the chat room told us that a 1920 tire on a Rolls-Royce would be around 7 inches wide. However, we should probably stick with 8 inches because, or I don't know, do whatever you want with that information.
Yeah, that's we were close. And again, if you went on Google and said, what is the width of a 1927 Dunlop 29-inch diameter tire, and you can probably find the dimensions, okay?
Mm-hmm.
In fact, there's a website I will show you those dimensions. Well, I can show you. I forgot about that. So we're saying, though, that for a 8-inch wide tire in HO, half the width is 1.168 millimeters. We got that much? So we figured that after various confused stumbling around. Now, so we're looking at a cross section that I'm going to want to print this in HO. It's 1.168 1.168. If I divide it by 25.4, it comes back to 46 thousandths. I multiply it by 87, it comes out 4 inches. So we know this is the correct dimension for this HO tire we want. But now we're going to say, am I good here? And this is where I click here and click there, and I go move my. It is 0.256 millimeters. That is not wide enough because the minimum wall thickness for FUD is 0.3 millimeters. Okay, this is the point where we're going to modify this for HO. So I click here and I go 0.31, and you say, well, Ed, you said 0.3. Because there's a software check, when we're working on curves, just add on a 0.01 millimeters just so it makes it happy. So I'm going to draw a vertical line, and I'm going to say, what is this thickness here? See, that's about 0.246. So I know that I want to come up, again, I'm going to come up 0.31. So I want that wall thickness to end right there. Okay? So what I'm going to do is, there's this little tool over here. See, it's called the offset tool. And have to maneuver all over the place. So what that does, it offsets from the edge. Now I'm just going to go delete the other junk out.
That was awesome.
And what that does, what? I went too far. Because see, I make sure my polygon's full, right?
Yeah. Oh, I see. Okay, you closed it out there. Yeah.
Okay, so I'm just. What I'm saying is now that for HO scale, written in FUD, and I can double check this, is I hit my tape measure tool. See, that's 0.328, that's 0.437. You can come in there and try to make it, but I'm just doing a quick and dirty tutorial.
Yeah, that's our style.
Right? So now, okay, we got this. I don't like that. I'm saying, for some reason, camera, see, it gets wonky if I just want to make sure, okay, that is flat, right?
Mm-hmm.
All right. So now, that is the tire profile that I want, right there, that we're going to spin to make an HO tire. And people go, well, it's too fat. I go, well, okay, then
that's on the outside.
Go buy your own. This is the constraints we're working with.
Yeah.
In May of 2015, this is the constraints that we have. Someday it will be better. Okay. It is not. We're not there yet. Now, we also want a tire tread. So then if we actually pull up if I pull a screen up and I go back to, real quick, I'm going to open up my website. And the reason, that's not my website, darn it. Homepage. And the reason is, when I made some tires for my, if I can quit clicking stuff, the tires. I did some Google research. No. This is a tire I spun, and the tread runs not all the way to the edge. It's kind of in the center, right? So we want tread run up to right here. Got me?
Yeah.
So first of all, let's just cut the top part off so that, remember the little tool I used before, right?
Yeah.
Okay, the minimum detail on FUD is 0.1 millimeter. So what that means is, although we had 0.3 millimeter for the wall, the minimum detail is 0.1, and this is where you start playing around with numbers and trying to fake out shapeways. So I'm going to come down at that 0.1. That's minimum detail. That's the minimum drop of resin it will actually squirt out, is what they're saying. So I'm going to go back to that little offset tool, and I'm going to offset it so it's right. I'm actually going to go a little bit below it just to be clear, right? And so I'm going to say, let's say our tire tread runs to about right there, okay? So all we did through the entire process is just say, okay, I want my tire tread, and since the minimum detail that FUD they can produce is 0.1 millimeter. So here I'm just going to say, I'm just going to come up and go 0.06. Now, the reason for that is just simply, I'm not going to try to curve the tread around. Huh? Although we had 0.3. I'm sorry?
It's all good. I was making just another flob from me.
Okay. So I went in 0.06 because that comes up 1.2 when I double it, because this is the half the tire profile, which would be equal a little bit above the minimum, right? Now I want to move this. I want to be that 0.11, I say. That's fine. Because we're saying our minimum detail is 0.1 millimeter, so I'm just going a little bit more just so the software is happy. Okay? And I'm just going to draw a vertical line. And what I'm going to do is just, because we have a time constraint here, is I'm just going to select, now hold my shift key like any thing, just so I can select all three parts. I'm going to go M. I hit the control, and there's a little plus sign gets next to the cursor. See that? I hold my right arrow, and I move over 0.11. I go hit the X or times and 5. All I'm doing is just making copies. And the reason I'm doing that is this. And I'm going to say, if I select, hold my shift key, now I can do this, and this could be the raised tread, okay? Or I could have this the raised tread. So one gives me 2 and a piece. So I'm gonna say the tread should be, this should be the raised portion, right? And this is all, we're getting to the area of just, so I'm doing is deleting the stuff out. And that's, I don't like that. So I go back the other way. I could make this the raised tread. I'm trying to make it so it comes out. Okay, that looks better that way.
Yeah.
So we're going to say, and again, you're going to be looking at a drawing or a photograph of an actual tire and going, well, the tread needs to come. We're just playing here, right?
Yeah.
So the only part that might be a problem is this corner right here. It might fuss at you because it's less than 0.3 millimeters. Okay.
Now, what would be the problem with making that a slight angle towards the outside to cut that?
There's no problem other than
Pain in the butt.
no. I can make it easy enough. In other words, I can click here and click there.
Oh, that kind of makes it look a little ugly. I see.
Well, I don't know. Let's just leave it like that and just because we can see how it comes out.
One game.
Camera. See, I got it wonky again. So go back to the front. So we say, okay, I'm happy with that. And remember, we're saving as we go.
Yeah. Big point. Every time you say I'm happy with something, press save.
Yes. You know how that goes. Okay. From the top, these tires were around 30 inches tall. Right?
Yeah.
Well, just take my word for it. 29, 30 inches. So, remember, we're in millimeters, in HO, correct?
Yep.
So, let's make this a 30-inch diameter just because the numbers are easier to finagle. We take a 30-inch diameter tire. We divide it by 87. It comes out 0.344827, whatever. I multiply that times 25.4. That's a 8.75 millimeters, and I divide by 2 because I want the radius. So I got 4.38. I got a calculator, guys. I don't do this in my head. 4.38. So that's the radius for the HO tire. No, it's not. That is not the radius. Okay, let me try this again. Let's try this again. A 30-inch. Okay, let's just go to the radius. A 15-inch radius, right, divided by 87 is 0.172 times 25.4 equals 4.38. I zoom in and use my scroll button. And I'm looking, if you look down at the right side, let's do it this way. Sometimes I draw, I make a plane, and that's the way because it's easier to draw on the plane than it is out in the air. All right. So I'm gonna go 4.38 inches. So that's what am I doing wrong here?
You're trying to get to the center of the tire with this, right?
I'm trying to get. I often do this. I go, what am I doing?
Join the club.
We know that this tire is a little over 1.4 millimeters to the side. That's 4 inches, right?
Yeah.
So sometimes when you get like this and you get totally confused, right? What we can do is this. This is cheating. That's fine. I'm gonna make this. You look at the bottom. You see the little numbers appearing. I'm making that square.
Yeah.
Okay. We know that that 12 inches is 138 thousandths, and it's 3.5 millimeters. So I'm just gonna go 3.5. 3.5. So that is if I do a dimension, we know that this is 3.5 millimeters. So I'm going to say, I'm going to save where I got in case it blows up. I'm going to hit and go to 12. I'm just going to scale it back to full size, okay? And the reason I'm doing this because damn it, I'm confused. I'm going to come here down 15 inches.
Oh, I see what you're doing. You're gonna build it in full size here because the dimensions, you have to do a calculation on every single dimension we talk about. Now, is it going to make a difference when we scale back down, or is this?
No, it won't make a difference.
It's not bad cheating. This is good cheating.
Well, actually, I think I was correct. It just didn't look right.
Yeah.
So we're saying is that this tire, this is the center line of the tire right there.
Yeah.
15 inches from here to there. And if you look back at our, remember we said it was an 8-inch wide tire?
Yeah.
Okay. And part of this is that we're throwing numbers out there, right?
Yeah, and while we're throwing numbers out there, are we going to be able to use pi?
If you want.
Because I haven't used pi since high school, and my teacher said it was going to be used at some time, you know.
Okay, I'll try to use pi at some point. So the reason it was looking wonky is we were doing an old tire. We made it 8 inches wide, which is a fat tire that's more like a modern tire. Okay, so that's all that is. So here's our axis for the tire, right? There's our tire shape, and the only thing we got to do is double this up. So I'm going to make a copy. I make a group just so it. If you don't, it's liable to stick to itself, just like we did before. I'm just doing. If you look at the lower right, it says 1. Hit, and I'm just going to move this until they join, right? So there's my tire shape. I explode it, and I get rid of that. I don't need that center line. Now it's my tire shape. You click it, the whole thing highlights up, right? Remember we made our a little thing. Yeah, stop it. That's the wrong one. Oh, I'm gonna switch back to perspective mode, just so it makes more sense, right? So now I'm just gonna draw a circle. I click on the surface. I hold my shift key, so now and I click right on that axis, and I make a circle. I can change that to any size. Let's say I'm gonna make sure it's 60 S for 60 side circle. Here's where the magic starts. I select the path, is what we just did. We made a path. And that path is going to be centered. It's going to be a circular path centered on this axis. I click the Follow Me tool. I click that face right there. And now it's doing its computation. It's using pi. Okay, somewhere in there.
I'm going to email this to my teacher.
All right. And there is a tire.
Now that was magic.
Now when I'm doing this stuff, I leave that center line because at some point you're going to want to know where the stupid center. You're going to want to know where the center of the tire is. Okay, for moving it around in your when you're going to send it off or making an array of making more than one tire. No, it's blue, right? That tire is basically, according to SketchUp, turned inside out. These are the outside polygons. So I just select them all, I right click, I go reverse faces. Now it's good to go. This tire is ready to send off to be printed. Now, the other constraint in FUD is that the X, the Y, and the Z have to be greater than 12 millimeters. Now, first of all, I'm going to group that just to so I don't mess it up.
Pieces around within the tire, it's all one object now.
Yeah, so I don't actually click and draw a face or delete something or something like that. Of course, I would go. Now, see, I would not save this as the HO template, which I probably never did. I forgot to do. Remember, we saved it as the tire template.
Full size tire template. That's better though because we could change it into scales from there, right?
Well, yeah. But what I'm saying is, I don't want to save this as the HO template because I might want to go back and change the um, I should have saved before I spun it. So what I'm trying to say is this. Let's go back. Let's go Control Z, Control Z, Control Z. Come on, Control Z. All right. This point here, I should have said File, Save as HO version. I never put spaces in my file names.
Yeah, I put underscores.
Version 1 template, right?
Yeah.
And the reason is we make our tire and we come back and we go, oh darn, I don't like the way that tread looks. Rather than have to go through the entire process, right?
Yeah.
We save that as a template. Now, once we spin the tire, go back. There's my follow me tool right there. And go
This is the coolest part ever. Like, when this happened just a few seconds ago, I was blown away.
Well, because, see, we're doing a section of this tire.
Yeah.
And all we're doing is spinning it around that shape, right?
Mhm.
Now, see, what I will do here is for right now, I'm just going to right-click that line and put hide. It isn't gone,
Yeah.
right? And it's got some little glitch there. I'm going to hit E, hold my Shift key, so it only hides it. That's what it's doing.
Yeah.
And I'm hitting
Inside out.
reverse faces. There's my tire, and I'm going to go make group, and there's my group tire, right? And that will print at Shapeways. Now, again, I said the X, Y, and Z have to be greater than 12 millimeters, because the human hands actually have to handle this, right?
Yeah.
And so we said that was about 3 millimeters by 8. Okay, 3 by 8, something like that.
Yeah.
So that would be 3 plus 3 is 6 plus 8. If it's greater than 12, then they can print it. I would not print it this way because although it's right at the cusp, or maybe I would. It depends. What we do right now is we're going to do a test upload to Shapeways.
Perfect.
Okay? And what we're going to go File, Export, a 3D model. Now, see, I have to make sure that I'm in my the folder we created. Okay? Remember, it was in Micro Mimesys, and I had under, where is it? Tires and Wheels, Ron's Tire. I just go with the, it's not a template, this is HO version 1, alright? Just so you can keep track of what you're doing. This is a DAE, a collada file. That's a native, so it exports it. This has exported as inches because we're in inches, and that's a native thing. That's okay because we're going to convert it. I'm going to close this. I'm going to save the, save my changes, right? And I open up MeshLab. MeshLab is a free program. It's Italians wrote it, but it's an Italian computer course school for 3D stuff. That working 3D stuff. It's open source. It's free.
Yeah, it's at SourceForge. Cool.
So I'm gonna import the mesh. Now I gotta I go around to the to your folder. So it's in Micro Mimesys, my website, by the way, where I'm slowly building my little empire.
I was holding back from saying that. I'm glad you said it.
So I go to Ron's Tire, and there's the DAE file, and I open it up. I just accept that. Now there's the tire. See, it's a modern tire. That's why I was like, why am I wrong with the radius? And the reason was we were doing a modern tire and not an old tire. But that's fine. Okay. And what I'm going to do here, I'm going to do something. I'm going to see if I can do any fixes. I'm hit this little icon here are layers. Okay. And this is, by the way, where I can do multiple copies. If this will print okay at Shapeways, then I'll just make as many copies as I want. Okay? But right now, we're going to try to do a cleaning. We're going to clean and repairing, and I'm going to remove any duplicate faces. If I look down here, there's no duplicate faces. I didn't think it would be. Well, now we're going to go filters, clean and repairing, remove duplicated vertexes. It removed 3,316 duplicate vertexes. I right-click the inside the layers screen, and I go freeze current matrix, which just it applies the transformation. It will usually do that, but this is like a backup. Make sure that I'm doing what I'm supposed to be doing. Okay, I'm gonna export the mesh as. I'm gonna select STL. I'm gonna save, and a little screen comes up, which is on my other monitor. And you click OK. Now it's exported that. If you look at the STL file inside of it, you can actually export it as a ASCII text file.
Oh.
That is not inches, it is not millimeters, it's just units, it's just numbers. It's those dimensions we put in are going to be 3.5, they're going to be 8.1, it's no
undefined units.
Undefined unit. When I upload to Shapeways, they say what measurement system, I will say millimeters.
Oh, and so they'll make the
it will be exact to what we were working with. Okay?
Yeah.
Now, I got to check. This NetFab Basic, there's a program. I got to move it to the other screen. 1 second. It opened up in my other monitor, so I got to bring it over here. This is also free. There is a...
What is this called again? Sorry?
This is NetFab, NetFabb. Just do a Google search. NetFab Basic. You can pay $1,500 or something for the full up version, the pro version, like everything else. But this version does everything I need it to do, so that's just hunky-dory. Now, so I'm going to go to, the thing I like about this, it saves the last place you were at. So there's Ron's tire, and there's the STL file. And it opens up with a Danger Will Robinson, there's errors.
Wah, wah, wah.
It doesn't mean that the Shapeways won't take this. Shapeways actually, their error checking uses the NetFab Pro. Okay? And people say, well, why not let them do it? I say that's if you want to. I like to have more control over my own modeling than let some piece of software, I don't know where it's at,
do
it, right? If possible. Sometimes
you want to be able to track down where the issue is, and if you let other things take care of all, like automated features take care of things, you'll have a ton of problems tracking back to the...
You might have.
Okay.
In other words, I took out those duplicated vertexes. Shapeways checks would have probably taken them out, but since I'm in that screen, why not?
Yeah.
Okay, so I'm gonna click on the little plus sign that says, medic. Hit automatic repair. Hit execute, and it's gotta go through its little thing.
Can you take a JPG of that right there?
Yeah.
That'd be cool to put on the thumbnail for the video.
I'm running Windows 7, so I got the little snippet tool, and I got it as an icon. I can, in other words, I can do that, which makes a snipping tool. I can save that.
Sweet.
Or I can also export. What is it? Project.
PNG with a clear background or transparent background?
Well, you could. I mean,
I'm derailing the whole process here with, our style.
I remove, and there it is. And then there's no error. It's completely good, right? I go project. I go part, export part. As I don't want ASCII, I want STL. I overwrite the one I had. Yes, I want to replace it. Boom. Now that is a good tire. Now, actually, we should have looked at it. I forgot to, when we were talking about the size.
Yeah.
I
derailed it.
That's all right. I just open it back up. If you look down here, it's 30 millimeters by 8 millimeters by 30. So it's 30 millimeters across here. And it's 8 millimeters. Remember, we had an 8 millimeter wide tire, right?
Oh, it was an 8-inch wide tire.
Yeah, but remember, this STL file don't have any. It thinks it's millimeters.
Oh, I see. Yeah.
Remember, the question was, why do I work in millimeters? Why I did in inches? I did not have the constraints for the minimum radius. I export it, I import it, do the correction. It's in millimeters. That's what we want because it's a HO. I'm sorry. Well, it doesn't matter.
No.
It's because I'm giving I'm the thing is I'm jumping faster than I'm thinking. Okay, but I'm giving you the basic way this works. Okay.
Yeah.
But that came up. You know what? We forgot to do. This is full. This is full size. We forgot to reduce it back to HO.
Oh yeah. So you got to go back to SketchUp to do that, or can you do that in one?
There's a way to do it. There's a way to do it. In NetFab, the problem is I haven't used it. Let's see real quick.
You know, it's okay to have problems on this show because a lot of our viewers are probably going to forget something somewhere along the way, and demonstrating how to fix these things is the goal. It's the magic.
See, we had it in 8. We made it full size. It was 8 inches by 30 inches. It exported. Don't have units. It thinks it's millimeters, right?
Yeah.
Part. There's a move, rotate, slice, invert, edit. The thing is, I can go through this real quick enough without talking all the time.
Go for it.
In other words, I open up SketchUp, I go thing, I go file, up there was the tire, and real quick, I'm just going to go 12, comma, 12, see there's my foot, right?
Mm-hmm.
And we said that in a foot is 3.5 millimeters in HO, right?
Yeah.
So I go 3.5. So now it's scaled back to HO. That quick, right?
Mm-hmm.
So I go file, and this time I'm going to save as
BAE again.
Now we exported it, but I'm saving it as a HO version 1.
Mm.
That's already scaled and everything, right?
Mm-hmm.
So now I just sit there and I go export a 3D model. And you gotta go back and find your damn folder again. Ron's tire, and we're gonna write HO version 1. Yeah, I'm gonna override it. Usual stuff, right?
Yeah.
MeshLab. I go file. I go open. Not a project. There's a difference. A project is a group of meshes. You can save it, or you want to import a mesh. And real quick, we go right back to our folder. Once you find it, we go to tires and wheels, and go to Ron's tire, and I'm gonna. There's the DAE file. I go that. I'm not even gonna bother looking. I'm just go filters, clean, repairing, remove duplicated vertexes. If you see in the it removed them, I go that. I go freeze current matrix, which it says freeze the current transformation matrix into the coordinates ... whatever that means. All right, just it's like do whatever we did, right?
Yeah.
I go File, Export Mesh As. I select STL. I go that. You want to replace it? I go yes. It opens a little screen up. I go okay. I close this. I go back to NetFab Basic, which is over here. That's what I'm saying is once you do it, it's not that big a deal. You open it again, there it is. Click this, click the little repair thing, hit automatic repair, execute it. It does the little stuff, and once it's saying, you hit apply repair, move old part, you go part, export part is STL, overwrite the old one, yes, and it's done. That quick, okay?
Mm-hmm. It's good that we made this mistake, you know, because people are following this or may follow this in the future, and, you know, going over it all over again, you know, nobody's ever going to remember this stuff on the first try. So.
Right. If you look down here, they're saying length. They're talking about the width, right? It depends on which, you know, how you got the tire sitting.
Perspective, yeah.
Yeah, but it's 2.34 millimeters by 8.75 millimeters.
Hmm.
For SketchUp, remember X plus Y plus Z has to be greater than 12 millimeters. So we get 8, 8, 16, 17, 19, so like almost 20 millimeters. So like this tire will print by itself.
Oh, good.
Okay? And what we would do is I go back into MeshLab, I go to that layer screen, and I duplicate the layers. And I move the copy to one side, up, down, left, right, make it as many as I want, flatten the layers, 10 tires, 20 tires, 100 tires, make that one mesh, and I upload that to Shapeways.
Mm.
So now what we're going to do is we're going to upload that tire. Once I can figure out what to click, new window. Okay. I'm going to go to Shapeways, and we're doing this not to print the tire because it would be stupid.
Mm-hmm.
And the reason it would be stupid, I will show you in a second. This is why I go to the Design tab and to Upload. I go Select File. I go, you know, find where our file is, right? We go to Tires and Wheels, Ron's Tire. We go, it was HO version 1 STL.
Yeah.
Okay. Model units, millimeters. It's pre-selected. I go upload. Now we wait while it uploads the file. You notice the minimum file size, maximum 64 megabytes or 1 million polygons, right?
Yeah.
And we could have, it actually told us the size number of polygons. There's actually a way you can reduce your polygon count in MeshLab, but there's your tire. And now what it's doing now, it's going through its little internal
NetFab.
Yeah, it's doing. I'm pretty sure they're running a NetFab Pro as their checks, and it starts coming up. There are issues. Well, it's because this is quite strong and flexible. I mean, it has like a 0.7 wall thickness. Okay.
Yeah.
You can view the issues. For example, oh darn, is this wall thickness? And I click that, and it will show you. It says right here the orange is suspect. See?
Yeah.
But we're not wanting to do that. We're wanting to go, and I'm just going to go up here and go frosted detail. It's still loading in. Now look to the one side. Price $5.19 for that tire. Now Ron has a lot of money, but even he would probably say that's excessive, right?
Yeah, good one.
But what that is, of that, $5 is the handling fee.
Oh.
That's the fee that you're paying for the machine time. But say it passed. See this? And frosted ultra detail. Now frosted ultra detail. The X and Y is the same for both frosted extreme detail and frosted ultra detail.
Yeah.
The vertical, the Z-axis is 29 microns, or 0.0029 millimeters. on the, and it's 0.1, it's 16 microns for frosted extreme. Now, one tire is $5.19. You also got to look at a $5 shipping, so it'd be $10.19 for that tire. And Ron says, well, I'm not going to pay that.
So this, I think I know what you're getting at here. If we make an array of a number of tires, that price isn't going to go up by $5 with each tire.
Each tire is 19 cents of material, okay, for frosted ultra detail. 10 tires will be $1.90. So 10 tires will cost you $6.90.
That's not bad.
So now your tires are down to, well, you still got your $5 shipping, right?
Yeah, but you divide your total number by 10, and now you've got a much less price per tire.
Well, that'll be $11.90, right? So it'll be $1.19 per tire with 10
So we reduce the cost by 50% or 90%.
Right. Now, what if you put 100 tires? Now, it's not Ron, the hobbyist. It's Ed that has a little micro-mime site. So I order 100 and I sell them off my website, right? Now, 100 at 19 cents each, right? Is $19.
Yeah.
Plus $5 for the handling is $24. Plus $5 shipping is $29. But I divide by 100, it's 29 cents each.
Yeah.
Then I put them on my website. I say, and I've got on my micro-mime site, I actually got I can turn on a cart, like any website, right?
Yeah.
And shipping to normal people, like in the United States, is like $2. Shipping to Canada is like $6 or $7, right? Go figure. I don't know, but
they gotta kick the package at the border.
Yeah. So
hacky sacks. You know, Canadians, they love their hacky sack. You know,
right.
In shipping.
So order from my website. Then you would say I want 10 tires. It'd be $2.90, whatever the shipping is. So it's $7 to Canada, right? Let's say, and $3, for the cost and stuff. So it's like $10. So now you're paying $1 a piece for them.
Mm-hmm.
So that's kind of how you got to work it out. So I'm gonna go. When I finish that, I'm gonna go save changes, right?
Yep.
Now, no, I'm not gonna sell this tire. That'd be just stupid. But we're gonna go through the little thing. We go to details. Now, of course, you want a better title than HO1. You want a description and all that crap, right?
Yeah.
You select category. It's miniatures. And there's a miniature train, but it's not. I'm just going to leave it on miniatures, and I'm going to put it on HO. I save changes. That's for my Shapeways sites. That's if somebody does a search.
Yeah.
Like for HO or miniatures or whatever. And I'm going to selling. Now, here's where I can offer sales to others or not.
Mm-hmm.
I can display to the public, but the price won't show unless I click that button, right?
Mm-hmm.
I click in beta because it's never been printed. I want it in frosted detail.
Mm-hmm.
And so I say I'm going to sell this material, I'm going to sell this material. But look, Edward's just spent a while doing this stuff up. And most of my stuff, I add a 10% markup.
Yeah.
And one tire would be 51 cents. So in that case, I would say, again, that's ridiculous. I said that at the start. So
you've never, well, I know you have, but buying detail parts is pretty expensive.
Well, that would be $5.71 for that one, right? But remember now, if we had 100 and it cost me $24, I would add $2.40 markup, but you're talking about 100 tires, so that's only like 2.4 cents a tire markup, as far as I'm concerned. Because remember, we said, yeah, it was $24, right?
Mm-hmm.
So I would add $2.40 to that $24. So I would say plus $2.40, that'd be $26.40 plus the $5 shipping is $31.40. So it's 31 cents a tire now instead of 29.
Wow.
You know, excuse me for making a little profit. You know.
Don't do that. Don't be afraid to make some money because you know what? Your time. You know,
10%.
Right now.
10% is not. You know, so I'd mark these up to $5.85, you know, whatever. And you can see here, I added 52 cents and 53 cents. That was just 10% of that. If that was $29, it'd be 10% of that. So that's, you save changes, and then you go view product, and there's your tire on the Shapeways. And it's in my store, but I don't have
it for sale.
I don't have it for sale, so the price won't show up. If I show public profile and I go view shop, there it is. So there's, you know, and if I go 187th, it hasn't populated. It takes a little time to populate shots.
The site has been cached, so it'll take probably 15 minutes.
Yeah, whatever. You know, it takes a while. So this is my store. Like these, somebody ordered one of these the other day. These are cowl ventilators I did.
Oh, yeah.
And what they do is they order directly. They buy now a button, and you order directly, and it ships from Shapeways. But again, this is not really, if you're doing a ship, that's not bad. $10.91, $5 shipping. You got $16 for was it 10 42 and 34-inch cowl ventilators for a model ship. Okay, now there's nothing wrong with that.
Yeah.
But what I could do instead of this would be
print them in bulk and then sell them from home.
If I go to my Microminds website and I go details, ship stuff, ship fittings, right? So I go cowl ventilators. Let's go to the next page. Then here's the large. I go details, and so I got linked there as you can buy that many, or you can buy however many, and so on. See, and see, here's my. I've actually got 5 in stock, so it actually shows. So I can add 3 there. Go add to cart, and view cart, same as any shopping thing. See, I put $2.76 because I only ordered like 6 of them.
Yeah.
I'm just playing around with the cart.
Yeah.
But if the price dropped to 50 cents, then it would reflect that in the total. And I said a flat rate of $3. I should say except to Canada. But that is how you create a part from start to finish to post it up on the Shapeways site.
Right on.
And real quick.
Sure.
You said to me, we need to fix that.
Headphones, Skeeter. Headphones.
At which point Ron says, okay, I love that tire. I want 100 of them. Right?
Yeah.
And he's quite mad. I go, okay, Ron. I'll make you 100 of them fat tires, with a weird tread that looks like something on an airplane, right? And there's a way to make a regular tread. Basically, what you do is you make your tire without a tread, let's say, or with basically you make like a pizza pie cut on it.
Yeah.
You create the tread on that piece, and then you spin that pizza pie around to multiply your tread.
Yeah, instead of having a flat profile, you're saying make a one section with a section of tread in there to copy around your circle or follow around your circle.
Yeah, what I would do, I would make a tire with no tread, and then I would make a lug design for a tire, right?
Mm-hmm.
Separately. I would intersect that with that face of that no tread on the tire. I would intersect the faces. Now I had a pie section with one lug on it, and then I spin that lug around 360 degrees to make my tire.
Mm.
Okay.
Mm-hmm.
So it's a little bit more complicated, of course, than that, but here's the tire in MeshLab, right?
This is good enough for me.
Well, in other words,
I'm looking at an HO scale tire right now. I'll focus the screen on me for a second here. I've got an HO scale tire here, and I can't imagine having the tube portion on the inside hollow.
Yeah.
You know what I mean? There's
Well,
really no tread. The treads actually goes right around the outside, just like you've got.
Right.
And this is off my Frenchman riverboat.
Well, the reason I'm saying it's slightly more complicated is this. When I drew this tire, I used a 60 segment circle.
Yeah, I remember that.
Okay, I could have gone 120 or 400 or whatever. You don't need that because your number of segments are smaller than the resolution of the printer.
Yeah.
So it's like you just. But
it's going to get erased in NetFab anyways, or no, the one in between.
Well, I'm just saying, if you drop below the resolution of the printer, you just spin your tires. Ha ha ha. But if I was going to cut a section, you want an even division of 60. So that, you know, if I take 360 degrees and I divide it by 20, that's 18 degrees. Mm. So if I go 18 times 60, I'm sorry, 60 divided by, it'd be like 20 degrees gives you 18 sections, which means you would have to do a 20-degree section of that tire and then put your lug on that to fit so that when you spin it, you add, section to section to section, that the lugs would line up correctly. That's what I'm trying to say.
Okay.
But let's go back to this.
So what are we going to copy it now? 100 times?
You see this is the STL file we uploaded.
Yeah.
I right-click. I go duplicate current layer. I go filters. I go nominals. I go transfer, move center. I move this to one side so you can see. Okay. Hit preview. On the X, I move it out a little bit. Oh, let's move it out about, let's just try 5 even. That's too far. Let's go 3. My help, I hit the right keys. I don't want to get them too close. Let's put 4. Okay. Now I can. Ron said that he wanted 100 tires. So I'm gonna go up here. I'm hitting apply. You can keep that screen open, but I managed to blow it up a bunch if you're not careful. So I just close each time.
Yeah.
I'm gonna duplicate that layer, and I don't even have to do anything because I know the last numbers I used. I used 4 right on the X.
Yeah.
Okay. So I'm just gonna go nominals, move translate center. I'm just gonna type in 4, hit apply, hit apply, and make a copy. Say I duplicate current layer, filters, nominals. We're going to do this one more time. It helps if you can actually move your
This is where keyboard shortcuts come in real handy.
4, apply, close. Now I want to do it one more time, right? I'm going to duplicate this. Duplicate layer, filters, nominals, curvatures, and orientations. I'm going to go 4 on the x-axis. I'm going to apply, close. Now I got 4 tires. Now Control H, which centers everything, right?
Yeah.
I go up here on this, right click, and I go flatten visible layers. Boom. There's one layer.
So now they're basically grouped.
Well, I grouped, but it's one mesh now.
Yeah.
So now I can duplicate that. I go, damn it. I go duplicate current layers. Now I don't want to go in the X dimension.
No.
Well, I could, but
You're gonna go Y now, or
I'm gonna go Y. So I go normals, curvatures, and orientation. Move, translate, center. I hit preview so I can see what the hell I'm doing, right?
so it's gonna be a larger distance.
Say I'm gonna go Y, and see it went -11. So I'm just gonna go. Let's go -10. That looks good.
Yeah.
Control H to center again.
Oh, perfect. Look at that.
Okay. I went -11. And I can go. See now this. See the eyeballs. See,
Yeah.
as show and hide.
Yeah.
So I'm gonna click on that one. I'm gonna duplicate that. I'm gonna go. The reason is
So you can
I
copy
can-
it on the other side.
I can never type in a minus sign that it likes. Okay. It just.
Hey, Ed, what about the sprue?
Well, in this case, because it was greater than 12 millimeters, you don't need a sprue. The
Okay.
sprues only need if they're below X plus Y plus Z equals 12 millimeters.
I don't understand that.
All
I
right.
thought we were gonna put the sprue on sometime.
1 second. 1 second. Let me remove this. We said 10. That's Y. That's X. Damn it. 0. Y. 10. There it is. Okay. Now, what don't you understand?
The sprue, the thing that's gonna connect all these together.
You don't. Look. The minimum size they will print, X plus Y plus Z, has to be greater than 12 millimeters. Okay.
Okay.
This tire is 2 by 8 by 8.
No, but what I mean, you probably know exactly what I mean, is like when you're printing something, like it just doesn't print it and then it drops onto the table. These are all connected in some way, aren't they? On the table as they're being printed?
I see what you're saying. When FUD is being printed,
Yeah.
the print head spits out two things: an acrylic polymer,
Yeah.
which is your FUD, and a wax. That's called
Oh, cool. Oh, wow.
And the reason for that is so you have overhang. So it lays down one layer of either wax or polymer, depending on whether or not it's something's there. A UV light comes on, hardens the polymer. The table drops 29 microns. The print head goes back to the other side and prints the second layer,
So
wax and polymer.
the wax encapsulates our model during the printing process to keep it all together, like package it.
Okay, think of your inkjet printer.
Yeah.
Now, you did a vertical section of this tire.
Yeah.
Okay, from sidewall to sidewall. And each layer is 11,000ths of an inch, and the reason I say 11,000 is because I say that's the thickness of a 120-pound cardstock. And so you print on your inkjet printer every one of these. You go print, print, print. It it starts small and it gets bigger like a donut. And it makes the tread side, it gets smaller. So you've got your entire tire printed from sidewall to sidewall.
Yeah.
You got white paper and you've got ink. The ink is your polymer. The white paper is your wax. Stack your cardstock up into a tire, glue it together, cut away all the white parts. You got a 3D printed object.
Yeah. Yeah.
All right. So we just duplicated this, and that last one I went. If you look, that's the last one I did, like the merge mess.
Yeah.
If I want to, I can go rename and call it Ron's Big Head, you know, whatever. So
this is Ron's brain.
Yeah.
All holy.
So now we went this direction, and I just moved it 10, right?
Yeah.
So now all I can do is just hit there and go duplicate, and I can go now we're
the other axis,
right? And I just go normals. I go damn it. I go move translate center, and we moved X. No, we moved Y, right?
Mm-hmm.
And moved 10. Oh, we got preview. And there it is. Right? And I'm gonna do it one more time. I'm gonna duplicate the current layer. I'm gonna go File, Filters, Normals. You know, if I could ever read the instructions, there might be a way to do this. Okay, so now we got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5.
50. Or no, the 25.
That would be 25, right?
Yeah.
And Ron says, well, I want 100. So I go flatten visible layers, apply, close, duplicate.
4 times.
I go filters, move translate center, preview. Let's move on to Y. No, I don't want that. I want to move on to X. So, well, and it's going to be even number because we did even before, right?
Yeah.
And I go, okay, now we got 50. And now, Control X, because there's a the print box. I mean, the printer itself, there's a bounding box that it can print in, right?
Yeah, the table is only so big.
Right. So these aren't too big, but I want to go vertically. So I go, and you can look on there. FUD is 200 by 184 by 203. It's about 11 by 7 by 8 inches. Okay, and we're not outside that. So I'm gonna go filters one more time, normals, curvatures, and orientation. If I can move, translate center, preview, and I'm gonna go Z, and I can move it around to see where I'm doing. It's 12. Let's go 10. Oh, I put 110. Okay. Apply, close, and I can do the same thing. Now we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5. So that's 100 tires. I sit there. I'm going to flatten the visible layers, hit apply, close, right?
Yeah.
I'm going to file, export mesh as. I'm going to export as a STL. Now, if say there's a project, I could save each layer.
Yeah.
Which, because after you merge your layers, that's when you come back and go, oh man, I wished I had
25.
Yeah, 25, man. 100.
99, yeah.
Mine's tires. Okay, we call this tires. So I'm exporting that as 100 Ron's tires, right?
Yeah.
I hit the little OK, it pops up. I'm not going to bother running through MeshLab because we've already got a good we did that, see?
We cleaned those vertices up.
We already cleaned all that crap up. All I gotta do now is I go to a new window to shape. I go back to Shapeways. I go design. I go upload.
So before we had $5 a tire.
$5.19 plus your $5 shipping.
Okay, $10 for the whole kit and caboodle.
So it's millimeters, so I can upload and wait to. No, this is 100 times the size of file, so it takes longer. I mean,
how big is this file? Just so we know, because it's 60 megabyte limit.
1 second.
Oh my goodness, that's small. That's not even a meg. It's like 1%. What is it?
It's 120 kilobytes.
Oh. What's that?
And that's,
What's that? How big is that?
It's 120 megs, which means it's outside the.
It's too big.
It's too big. If you look, your 1.202 kilobytes for one, right?
Yeah, that's a 1.2 megabytes then, right?
No, it's 120 megabytes. These are kilobytes. There's 3 zeros after it.
The single, yeah, okay. You talk, not me. I'm not the expert here.
Kilobyte. At kilo, you're in Canada. Kilo means 1,000, right?
Yeah.
118,000.
Yeah.
Are 120 megabytes. It's 120,000 kilobytes, or 120,000 bytes, or 120 million. Okay?
Yeah.
So, yeah, it's going to come up and it won't load. Right?
Yeah.
And Lon says, oh, I so wanted those tires. And Ed says, well, let's open MeshLab. Recent files. Let's import the mesh. We got to go back and find it. This is the sort of thing that the reason I take 10%. Beyond, damn, it's my company.
Yeah.
But this is the sort of crap you guys.
People make money for sitting down all day and like answering phones and stuff like that. So.
Oh, I'm just saying it's more to it than just just tossing out. So we got to go back, go to Ron's Tire, go to something, and go.
Never be afraid to ask for what you're worth. That's a piece of advice in this hobby. If you're volunteering your time, go for it and volunteer your time. Everybody will appreciate you for it. But if you're taking your time out of your family's life, if you're doing sort of things that is like for somebody else and you don't feel like volunteering, charge what you're worth. Don't be afraid. A lot of us out there will be right behind you.
I couldn't agree more. I could absolutely.
Looking at that, we could have seen that there was a problem. It shows 123,000 vertices and 2,460,000 faces. Well, remember there's a 1 million polygon limit.
Oh my goodness! So
beyond the 64 megabyte, right?
Yeah. So we're out of ways.
So let's go filters, remeshing, simplification, and reconstruction. Quadrant edge collect decimation, and look our target number of faces.
So you can put boundaries and have this try to fix it? Cool.
Well, no, it remeshes. See, it has 246,000. We want 1 million, right?
Yeah.
So let's go 1, 2, 3, 4, 5, 6. Apply. I hope it won't blow up.
Yeah. This is where
Sometimes
this is where the Muzak comes in.
we got 500,000 vertices and a million faces.
Okay.
Now, and the as far as the tire is concerned, it don't give a shit, right? I mean, you can reduce it till it starts getting like wonky looking because it starts getting like sharp edges and stuff. But we're not. We only reduced about 50%.
Okay.
So let's export the mesh, and we're gonna just for comparison, we're gonna STL, and we're gonna say this is Ron Tires 2, right?
Version 2, yeah.
Okay, let me close this. Like, what did I do? Close the screen? No, it is. Yeah, it's still loading. It's not when it loads up. It's gonna go. I don't understand. I'm confusing. So I'm gonna close out. I know it's no good. It's no use waiting for that, right?
Yeah.
But let's look at our. Let's go back and see what it is now. Micromimesis, tires. This is all good. This is good training. So it runs tires. And now it's down to 48 megs.
We win.
Okay? So I go back to Shapeways, and sooner or later it's going to go, you may have a fault with your file. You need to recheck it. That sort of junk, right? They don't say you're an idiot. They just go, there's a problem with your upload.
And then there's an acceptance of being an idiot, and you just say print it anyways?
No. Yes and no. You keep asking these things. It has to be below 64 megabyte file size.
Yeah.
We're at 48. It was at 120, so it won't take it. It will just refuse. Your file's too big. It has to be more a million or less polygons. We were at 120 million or 240 million or whatever the hell it was. We dropped it down to a million. The print anyway is, it comes up and says, there may be a problem with this, the walls may be too thin. And Ron says, I don't care, print it anyway. In which case, they're going to print it anyway, and if it screws up, you're still going to get charged for it because you told them to print it anyway.
Mm-hmm.
That's what that is. So, yeah. Not only did we upload a file, we Ron Pare joined a video call. Okay. If you go to models, so there's a version 1. If I show unprintable models, there's some stuff that I, for some reason or another, didn't print. And after it decides that I'm an idiot and I uploaded too big a file, it'll tell me. But now, we can try this upload again. Select file, we go to number 2, hit open, it's millimeters until upload, and then you can, you can do more than one file because they got big servers, right?
Mm-hmm.
Now, I said 1 million polygons, and hopefully it's not 101 million and one or something crap, right?
Yeah.
I'm always suspicious of software because that's why I made the tire thickness 0.31 millimeters, although 0.3 millimeters is the minimum.
Mm-hmm.
But when you start taking a shape and you start making a curve, you run into, you know what I'm saying? It's that damn
getting out of the tolerance.
It's that pi thing.
Yeah.
Pi is a radical number that it never repeats itself.
Yeah.
3.1415. You know. So, and a computer, remember, doesn't in numbers. It's even numbers. It's decimal. So if you have a thing if you divide 1 by 3, you get 0.33333333 forever, right?
Yeah.
So just to be safe, I bumped that 0.3 to 0.31, so no rounding error is gonna go, hey, you got the wrong size.
Mm-hmm.
You know, so
everything's gonna work in your benefit. If it's a mistake, it's gonna be a benefit. A mistake that works.
I showed you the cowl ventilators I did.
Yeah.
And I used a plug-in to make the shape. They came out real good. They look good. I think they're excellent little models. If you look at, I'm ringing my own bell here or whatever it is. But I'll go to a picture one. If I go to my ship stuff, if I go to my cowl ventilators and I go to the N scale, that is an N scale cowl ventilator. Now, when I was printing this the first time I uploaded it, aired out the wall beam tooth, and the reason was when the software curved this thing around to make that funnel shape.
Yeah.
At some point, it dropped below that 0.3 millimeters.
Oh.
You know, because you're doing a lot of math. Because here's the shape, right?
Oh, there's multiple planes on this.
Oh yeah. So somewhere, this inside surface where it curved around right here, the thickness was below 0.3 millimeters.
Oh, I see. Yeah.
So I bumped. What this is basically are two shells and then merged. There's an inside and an outside.
Yeah.
Okay. And there's a real cool plug-in, a free program that enables you to it basically, you tell it, here's the opening, here's the end, here's the path. Create a mesh that joins this and this along this path, right?
Yeah.
So at some point in here, it was too thin. So you notice it's 15 thousandths. 3 millimeters is 12 thousandths. So I just bumped it up to 15 thousandths, and it went through fine.
Cool.
Say, there's the.
So what is our model still processing in there?
I don't know. What's it doing? It is
still processing.
Well, it's uploaded the file. The file's uploaded because you see this screen.
Oh, okay.
Now it's doing the checks. Say when it says upload, that's just the server uploading that 48 megabyte file.
Yeah.
Okay? Now it's running through the processing, and it's going to see. This is the software check portion. This is the. Now I said at one time I read that they were using NetFab Pro, but they also got some their own software and who knows what, right?
Yeah. Whiz bang something.
Yeah, some whiz bang, high speed, 3D, because people can send some really screwy files and they fix it. Okay. Oh. But see, this is all materials. Strong and flexible, that's your nylon.
Yeah.
Metallic plastic, frosted detail, that's what we're looking at. Acrylic plastic, stainless steel, precious metals, including a 14 karat gold. But these will be like $1,500. You know, it's like, but there's also raw bronze. And all these things are these precious. I don't know why they call raw bronze a precious metal. That's where it appears. But what these are actually they print them in wax, like this. This is a cast of wax. They print them in a wax, and then they do the old way the jeweler's been doing for 3,000 years is you embed it in a plaster, you burn it out, and you pour in the metal.
Yeah.
So yes, these are expensive because you can imagine how much time that takes.
Yeah.
I mean that's.
Oh, so they don't print in the metal. They print in the wax.
Lost investment. It's a lost wax. The old school lost wax investment casting.
I had assumed that they actually found a way to print in the metal. Oh.
They do for the stainless steel.
Oh.
But that's not a pure stainless steel. That's in other words, think about it. It's like mixing a powdered stainless steel with epoxy.
Yeah, yeah. That's always what I thought it was all about. Yeah.
No, this stuff here is they print in wax, and it goes into a little, like a can, this plaster goes around it.
Yeah.
Puts it in the oven, burns out the wax, they pour in gold or whatever.
My goodness. And that's awesome for, like, you know, a slug for making a master. You know, if you didn't get your treads right in that tire, you come back and finish off the carving off of it and then make a master of it and go for it.
Mike Slater was rebuilding some old engine.
Yeah, he's a big Lionel.
Yeah, big Lionel guy. And what he did was made he had a raw bronze cast and he turned it on a lathe.
Mm-hmm.
Like a driver's.
Okay.
No, I mean, what did he do? He had the, I remember what it was.
We're running a little late.
Yeah, he had the center cast and he pressed it or something into the rim.
Oh, okay.
Something like that. Well, it's still loading.
Okay. Well, I can wait. I've got people getting my stuff ready.
Right. So.
My people.
Your people. You have people. My people get with your people.
Yeah, they're kids and.
But yeah, that is worth looking at for model railroading. If you were wanting something strong enough, the raw bronze or the raw brass or whatever it is.
Yeah.
The raw brass right here. It's actually like. Do you want a brass driver? Do you want the brass driver on the rim? Of course not. But if you could turn or get your hands on a nickel silver rim, you do like they did in the old days with the steam locomotives. The rim was pressed onto the wheel.
Yeah.
So what you do is you have them print this, you turn it, and you press it into a rim. That way you can get any shape you want or any spokes and everything.
Huh.
Right?
Yeah.
And you got the constraints with no, it's got this far, it's got as far as the picture out. You got the constraints of the material. That's what I'm trying to say.
Yeah.
So if you go to materials, I'm just going to open this in a new screen so we're not, unless I'll go to metals, brass. This is their 3D printed brass. It's got a $20 handling fee, which makes sense if you stop and think about it.
Yeah.
That's polished. Oh, the raw brass is $10.
Oh, okay.
It's $16 a cubic centimeter.
That's funny because they just throw that stuff into a can and it turns around under those little stones and it polishes it. It's not like somebody's there polishing the thing.
Look, Mr. Ron, I'm just reporting the stuff. Your bounding box is 89 by 89 by 100 millimeters, so it's an inch by, what, 3/4 of an inch, something like that?
Yeah.
Okay, so it's not very big. Jewelry, basically, right? Minimum wall is 0.6 millimeters for the raw brass. See, the polish is going to be thicker because it gets beat around, I guess. And then your wires, if it's a sprue and that sort of stuff. And so you go to that screen for your, as long as your driver is below 1 inch in diameter of the wheel, you know. Okay. And then you go, well, why is $157 for the strong and flexible? Because they charge $1.50 per part, and that's 100 parts. This, in case if you were going to do this in white, strong, and flexible, yes, you would want them on a sprue. Because then it would be 1 part. See how that works?
Mm-hmm.
So at $1.50 a part, that's $150. The actual material is only $7.96. Now, and there's issues. There's issues. It's wall thickness is what it is, right?
Yeah.
And there's issues. It's all wall thickness because we're using the FUD thing, right?
Yeah.
And that's the one with the smallest walls. It's still loading in, and I don't want to see the other crap, so I'm gonna click frosted details so only those two show up. Now
$3.
it's $23.93. Now think about that, $23.93, right? Plus $5 shipping, so it's $28.93. You divide by 100, and it's 29 cents each.
Wow, that's killer.
So,
that's not so bad.
that was a point I was trying to make. If all of a sudden everybody in model railroading land wanted these little wheels, tires,
yeah,
then I could say, okay, I drop $29, and I have $28.93 to my door.
Yeah.
100 tires. I'd turn around and sell them on my website for, and since they were 29 cents each, I would add 3 or 4 cents markup each. So that's 10%.
Yeah.
So I'm selling for 32 cents each.
Yeah.
I'm only making 4 cents each. And which is really ridiculous, but I'm not trying to make a living
That's
off
unrealistic. That's unrealistic, but yeah.
But I'm just doing this for the fun of it, right?
Yeah.
And over a period of time, you make a few dollars.
A box of craft dinner. Yeah,
The big thing is I would like to be able to go to a convention and sit at a table with one of the other manufacturer guys over there.
That's a good point, though, Ed, because you're going to have to drive your butt down to that convention center. You're going to have to rent the table. If it's a union freaking place, you're going to have to get somebody to carry the box in for you.
Yeah, but
I don't think that's a joke. That's for real.
It's ridiculous. It's extortion.
It is. But, so charging yourself out accordingly to be able to go to that show is something that you also have to do for if you're sitting at home, because you got to charge yourself properly so that you are capable of going to that show and selling your stuff.
I understand, and that for example, Mr. Lincoln,
yeah,
he's knocking on he tacks on $2 or $3,
which is not unreal. The price becomes unrealistic when it's at the top end.
Right.
But if you're under that top end,
well,
go for it, Mr. Lincoln.
He's making those bolsters for this. It's making
the Lionel gondola car.
Yeah, and box cars. The car itself is scale. it's just got the funky, Lionel bolsters and wheels and all that, right?
Yeah.
But what he's doing is making scale bolsters to fit that Lionel body. Now it becomes a P48 kit.
Yeah.
So, whatever he's doing a white, strong, and flexible, but he's done it from somebody. They actually got a white that's actually not as grainy. But he's doing that. He's tacking a couple of bucks onto it for his portion of the goods. So if it's if somebody's gonna build a Lionel O scale, and they're gonna spend, I don't know, $8 or something for a bolster, then it's 13 or 12 or something like that. So he's making some profit.
Yeah.
I would be if it was $8 for me, I would be doing 80 cents with my 10%. I just did that, just a starting place. And I'm not trying to make a living. I'm doing this stuff for me, and people go, "Hey, can I get a copy?"
Yeah.
I said, "Okay, I'll throw away. I can make enough to pay for my website."
Yeah. And you're basically volunteering a lot of your time.
Well,
so,
but here I'll show you. I'll just show you inside my thing. Let me look at my sales. Let me open link a new tab. I made
50 cents.
Well, let's see. This is past payments. It was I don't know if this is a running total or what. A market fee was $1.10. Oh, it was 32. So it was like $30. I had like $1. So these are what did I sell for 33? Oh, this is a running total. See, all these truck bolsters, I'm not even charging them because they're not mine. They're actually
I'm getting the word. I gotta wrap this up, Ed. Is that okay?
Well, it's just okay. It's just it's still loading the auto checks, and it'll probably be okay since the one was okay. There they are. Look, it just passed.
Oh, okay.
All right. So I save changes, and I'll go to selling, and I go offers to others. This is Ron's tires. I go to beta. I go down here. I want frosted detail. I want to sell it in this material, and I'm gonna add. It's $23.93, and I'm gonna add a 10% markup of 24 cents, so it's $24.17. Save changes, and if you buy that, plus 5 is $29.17, so it costs you 29 cents a piece.
Wicked.
And that's how that works.
Wicked. I'm gonna get the client to buy it and send it to me.
Yeah, but we didn't get. Well, that's how you make a tire.
Yeah, we can get into other stuff at a later date because there's a lot of stuff for people to chew on right now. You know what I mean? So the one thing, real quick before you take off. Sure.
And you looked at that and you said, Ed, darn it, that was neat, and there's that tire, but it's too new, right? And say, oh, darn, I wish that thing was like an old-timey tire because this is, out in the country. Oh, well, how about hit S and go, scale it down.
Now it's a tractor tire.
Or whatever. Or I can get S and scale it like that. Well,
now it's a field tire.
I'm just saying that's
it's all pretty easy.
If I wanted just a little bit wide, Now, we'll see, the problem would be these would not meet your 0.1 millimeter because we squished it down. See?
Oh yeah.
See?
So
now
you
they're
the size of
it's like 0.8, a 0.08. It's not. It's well. What I would do would be, I would take the original tire we had.
remove the treads, or
What I would do would, real quick before you go. Well, actually, what I do is just spin a new tire, But just saying that you could also, if I do I would do a. Well, I'm gonna get down here. I'm just trying to find the edge of the tread, right? See I'm trying to. Okay, it's right there. It's the edge of the tread, and what I would do would just be something like this. I would do a. If I can get, there we are. And then I would sit there and I would explode that, and then I would intersect the faces with the section, and what I would end up with would be I'm splitting that tire, the sidewall off from the thing, and I just make a copy so I can have one to play with. I come over. Yeah, I went the wrong direction. That's okay. Come on, stop. Okay. Then I would just all that is if I looked at that thing from above, is see that I can basically split that thing off. See, and I can make like a new it's so what I would do is split the tread. I would split the tread.
You can slice off a portion of it and make it smaller.
Yeah, because I just put a plane through it and intersected the faces. So now this plane is inside the other thing, and so I could slide the faces off, cut the tread down however wide it was. See, that's just dumb, because it'd be just simpler just to, which I didn't save the template. Remember we said we needed to save the template in case we wanted to do something different?
Yeah.
It would be you saw, if I wasn't talking, it wouldn't take that long to draw that profile.
And the other thing is that, we designed that tire for HO scale. If you're going to design the tire for something else, it took you about 45 minutes to actually do the tire, so to do another tire won't be, it's not like carving out a tire, which could take you the whole day.
But notice how long when I messed up and I had the wrong size? It took me, 45 seconds to sit there and go through the entire process?
Yeah, exactly.
It's in other words, if I was going to do a tire, I would look online and say, okay, I would say, I know you got to go, but real quick, I was going to show you this, and I totally got,
It's Mother's Day. I'd say I don't care, but
okay. Here's what I'm saying. This is what I actually looked up. 1920 said outside diameter is 30.4. Section width is 4.3 inches.
Half the size? Oh well.
That's from here to here is 4.3 inches. Rim diameter is 21 inches. Rim width is 2.75 inches. See, this is everything I need right here.
Yeah.
To do that, right?
Yeah.
Here is other tires.
Now we got the honking horns.
You got problems, kid.
Yeah.
Okay, bye.
So thank you, guys. Thank you, Peter, for coming on, for your moral support. Thank you for all your demonstrations today, Ed. Unscripted. This is not an easy thing to do. I'm sure everybody in the audience can tell that, doing things on the fly like this isn't very easy. So thank you for everything you've done for us today.
Well, I think that screwing up is what we all do.
Oh, it's something.
And it gives confidence to everybody else.
That's my style. I love it. You know, a lot of people are really worried about showing unfinished work online and stuff like that. You know, you get the pundits' opinions. You know, the talking heads who are perfect in every way. But you know, it's not like that in real life. So to show the mistakes is important. But
you look at it and you go, Ed, you got that 8 wide and 30 tall. Oh darn, we left it full size. Okay, you know, it's like I messed up. Let's fix it.
Yeah. No, I agree completely. That's my style. I love that.
Well, if your style wants to continue to live, you better go.
Yeah. Well, no, actually, I just want to tell everybody that since this video kind of really won't fit into a show, I'm going to cut it down drastically for the show, but I'm going to keep this raw video live forever. Some shows I just going to pull down the raw show after the show comes out because we kind of do double up the content in a certain way. But this kind of video right here has an application for somebody who wants to watch, who notices it from the show. Will be linked to this video, and you can watch the whole thing for the 2.5 hours or whatever it was we did.
You can watch us screw up by the numbers.
It's a train wreck. Anyways, thank you guys for coming, and I gotta go. Otherwise, I'm gonna be hung.
See you guys.
All right.
Bye, Ed's cat.
Bye. Bye. Oh, hey, Kendra, what's up, buddy?
There we go. It's not a show until we get a cat. Talk to you later.
All right.